Well, good evening, everyone. My name is Colin Williams. I'm an Ohio native, a husband, a cat dad, a musician, and I'm a senior front-end engineer and architect at ecosystems.io, the leading software as a service for B2B value management. So let's talk generative AI. Large language models are changing the way we interact with technology. As AI chatbots become more ubiquitous, users are starting to develop expectations surrounding AI chatbot experiences. So what do users expect from AI chatbots? Well, let's take a look at the most popular AI chatbot, ChatGPT. The user types a message, hits enter, and the AI generates a response in real time. We can also see a blinking cursor at the end of the message to show that the AI is working. With the growth of generative AI, it's likely not a question of if we'll ever need to add something like this to our apps, but when. So how do we create experiences like this in Angular? Let's take a look at what we're creating. The user types a message, hits enter, and the AI generates a response in real time. You can also see a blinking cursor at the end of the message to show that the AI is working. For simplicity, I'm using the Google Gemini behind the scenes, which is free so long as you're willing to sell your soul and all your data to Google. On the back end, we make a call to the Gemini API with our prompt. And as the AI generates content, we stream each chunk of text to our response. And once the AI finishes, we end our response. Now, on to the front end. The first thing we need to do to enable this real-time data streaming is to provide the HTTP client withFetch in our app config. This tells Angular to use the newer JavaScript fetch API behind the scenes, which opens the door to more advanced features like this real-time data streaming. The actual UI code for our app is pretty simple. We have a for loop showing a list of messages and a form for the user to send messages. For the actual messages, we use the ng-class directive to add the generating CSS class while the message is in progress. To create the blinking cursor effect, we use the CSS after pseudo element to add a block character for the end of the message. And we use the keyframes animation to fade its opacity in and out. Now, on to the data side of things. Our custom message service is responsible for both managing state and real-time data streaming. We do this using a combination of both Signals and RxJS observable streams. Signals are great for managing state, but RxJS is perfect for asynchronous events like this real-time data. We have 3 writable signals to keep track of our internal state: our list of all messages, our list of completed messages, and whether generating is in progress. Out of these 3 signals, only 2 of them are exposed to the outside world: our list of messages and generating. And note that these signals are marked as read-only, as we don't want outside consumers changing their values. When a user sends a message, the first things we do are set generating to true and create a message object based on the prompt. Next, we subscribe to a stream of the LLM's response. First, we use the Angular HTTP client to send a post request to the backend containing our prompt. Since the backend is streaming small chunks of text over time, we need to tell the HTTP client to observe events and report progress. The HTTP client is going to send us all sorts of events, so we can use the RxJS filter operator to get only the types of events that we want. Once we receive an event, we can use the RxJS map operator to transform it into a message object. If the type of event is download progress, that means the AI is still working. So we grab the partial text and set generating to true. If the type of event is response, that means the AI is done. So we grab the full response body and set generating to false. The last thing we need to do is use the RxJS startWith operator to set an empty message object as the initial value for our stream. That way, the user still sees an empty chat bubble as they're waiting for the text to roll in. Finally, we update the state based on our stream. On each stream update, we set our list of messages. And once the stream completes, we set our list of completed messages, and we set generating to false. And if the stream errors out for whatever reason, we still set generating to false. And that's it. We now have a functional, clean AI chatbot experience in Angular. As a quick review, we provide the HTTP client with fetch in our app config. We have the HTTP client observe events and report progress. We create a blinking cursor using the CSS after pseudo element. We manage our state with signals. And we react to real-time updates from the LLM with RxJS. If you want to continue your learning journey, you can see all the code from this presentation and more on my GitHub. Just scan this QR code. If you want to learn more about me, check out my blog, or contact me, you can do so on my website, colinaw.com. I hope you all have a good night and a great ng-conf. Thank you so much.